Good afternoon. Today we are going to work through as much as possible the Unit B review. And it has a lot of stuff on it. The first thing is recognizing how to do greatest common factor. So recall, if you look at these numbers, 3 and 3. Now, when you think about it, the largest number that could go into 3 and 3 is 3. So right here, H, like there's no way it could be H. That's a 6. Okay. When you factor something, you have stuff in parentheses, so it can't be J. And then on K, again, it says 6. So immediately I could cross off H, J, and K. So I see that there is a 3 in common. So I factor it out. 3 and 3. Next, let's look at the x. I have an x to the first, and I have an x to the fourth. So that's 1x, and then 4 x's. How much do you have in common? You only have 1x in common. So now it should just say x to the first. And then finally, y to the fourth, and y. What's the greatest amount of y's you have in common? 4 y's and 1 y? Just 1 y. Divide that out, and you're left with y cubed plus x cubed. So I would say the answer is G. Okay. Number 2, Zachary graphed this function below. Now, notice this is in vertex form, so we would say that h is 2, k is -3. You may be asking, why is h not -2? The formula for vertex always has a minus. So when you're talking about the h value, I guess you could think of it as just the number that's there. So if this had said +2, then you would say h is -2. All right, so he graphed it below, right here. He then wants to translate it 7 units to the right and 5 units up. What would be the new value of h and k? So what I'm going to do is all you really need is the vertex. So you're going to go 7 units to the right. So 2 plus 7 is 9. And I believe that says 9 right there. So you're going to go 7 units to the right, 5 units up. So 7 to the right. And then this is at -3. So 7 units to the right, and then 5 units up. The new vertex would be right there. And if I wanted to draw the graph, it would look kind of like this. Ooh, that doesn't look very good. Obviously, these are not the same exact shape. I free-handed it. But now, what would be the new value of h and k? I moved it 7 to the right, and I moved it 5 units up. Now, this vertex looks to be 9, 2. Okay, so the new h value would be 9, and the new k value would be 2. Okay. In other words, if you start 2 to the right and you move it 7 to the right, that now becomes 9 to the right. And if you start at 3 below, but then you move it 5 up, then that becomes just 2 up. So that would be my new value of h and k. My number right here would be 9. My number right here would be 2. Number 3, you tried to graph the following function. Identify each of the following properties as correctly graphed or incorrectly graphed. Now, it's better to work with these by factoring. If I were to factor each of these, I would not have time to go through every problem. So I'm actually going to show you how to get it from Desmos, just for sake of time. So 2x squared plus 2x minus 24. 2x squared plus 2x minus 24. Now let's see. Let's compare the y-intercept. The y-intercept here says like negative, maybe negative 12. What's my y-intercept? My y-intercept right here is negative 24. So those aren't the same. So identify each of these as correctly or incorrectly graphed. The y-intercept, that's incorrect. Let's see. Incorrect. X-intercepts. Here I have an x-intercept of negative 4 and 3, but it's supposed to be negative 4 and 3, so that is correct. The vertex here, negative 0.5, negative 12.25. Let's see what I got. It's supposed to be negative 0.5, negative 24.5, so that's incorrect. Whatever that word is, I don't even know. My fingers were in the wrong spot. Incorrect. Axis of symmetry is way over here. That makes no sense. Okay, so my axis of symmetry here is x equals negative 7. If I were to draw an axis of symmetry here, on the correct graph, it would be x equals negative 0.5. So that is incorrect. Now, is the graph opening up and down in the correct way? This graph is opening up, and it's supposed to open up, so that is correct. Okay, number 4, kind of the same process. You go and it says you tried to graph this below. Identify each of the properties as correctly graphed or incorrectly graphed. So y-intercept. And I have to type that in real fast. Y equals negative 1/2 x plus, what is that? X plus 4 squared plus 2. This is my correct graph. Okay. So let's go through them. They think the y-intercept is 10. It is sure not. It is negative 6. So that's incorrect. They think the x-intercepts they think they're imaginary because it never crosses the x-axis. It actually does have 2 real solutions at negative 6, negative 2. So that's incorrect. They think the vertex is negative 4, 2. That's correct, negative 4, 2. Looks like they think the axis of symmetry is at x equals negative 4. Let's go look. It would be at x equals negative 4, so that is correct. They think the graph opens up. I think I could show you it opens down because of this negative, so that is incorrect. Now, I'll let you graph the correct graphs above. Just for sake of time, I don't have time to do that. All right, another thing is you should be able to type something in Desmos and get all of this information. So let's type in 3x squared minus 6x minus 9. What is the vertex? You just go down here, put your cursor down there. Sometimes you have to click. It's 1, negative 12. Wow. 1, negative 12. The axis of symmetry is always x equals the x value, so it'd be x equals 1. You do need the x equals. The x-intercepts are negative 1, 0, and 3, 0. Pretty easy with Desmos. You could also get that by factoring, which if I have time, I might show you that. I'm just showing you the easiest way to get the answers. Let's see, y-intercept, that'd be right here at 0, -9. Domain, when you have a parabola and it's x squared, the domain will always be all real numbers because this is going to go to the left forever, that goes to the right. So domain is all real numbers. Now your range is always going to be y is less than or equal to or greater than or equal to, depending on if this opens up or down. The 3 says it opens up. So I know I'm going to have a minimum. So it's going to be all the values from this value and up. So it's going to be y is bigger than or equal to whatever that value is. And I guess I'll draw that one. Let's see, y is greater than or equal to, it's going to be this -12. From the graph, see, at -12, it's -12 and up. So that'd be -12, everything bigger than -12 and equal to. I don't want to do them all for you. I'll let you do this one yourself. I will do some of these for you, but below you will see 3 different forms. We call this standard form. What's nice about standard form is it tells you the y-intercept. So like right here, the y-intercept is 3. Okay. What's nice about this form, this is called, for v is vertex. We could look at that and say the vertex is 1, -4. That's nice. And then here, we call this intercept form or factored form. We could tell you the x-intercepts. So the x-intercepts are -3 and 1. So really, if you just type this into Desmos, -x² minus 2x plus 3, you could go find the vertex. And the vertex is -1, 4. So I am looking for the 1, because notice the vertex, I'll write it out, is -1, 4. So when I'm matching, I'm looking for the one here that says +1 and the one here that says +4. It's the opposite, same. So +1, +4 could be this one. None of the others are +1, +4. So I think that this graph goes with this graph. And I could fact check it real fast. If I type that in, it should be the same thing. -x plus 1 squared plus 4. Notice they are the same thing. That's another way you can match up the graphs. You type them in, they should be the same. Now they type theirs in as f of x. Same thing. See? Now, looking at this, if I factor this, I get the factored form. I'm going to go shortcut method, and I still have this graphed. I can see that the x-intercept is -3 and 1. So the x-intercept is -3 and 1. So that means that's going to make the factor x plus 3 and x minus 1. And I also need that negative out front to make it flip over. So what I'm looking for is I'm looking for negative x plus 3, x minus 1. That's close, just going up. No, x plus 3, x minus 1, where are you? Ah, there you are. So it looks like that this one goes to here. And I could check it in or type it in, negative x minus 3x plus 3. And just make sure it's the same thing. Uh-oh. Oh. I meant to draw it to this one. Remember, I said x plus 3x minus 1, then I picked that one. That was silly. Good thing I double checked my work. So yeah, this one goes to this one. I just did the same thing. I meant this goes to this. There we go. And look, they are the same thing. I clicked there, I can see the green appear over the blue. So that's how you're going to go through and match those. You're going to match one of these in column 1 to one of those in column 2 to one of those in column 3. Make sure you know how to do that. All right, number 10. Zoom out so I can read it. Graph the following function on Desmos, then draw on the graph below the vertex and axis of symmetry. That's super easy. So I just type that in, 2x squared minus 4x plus 5. And they want the vertex. The vertex is 1, 3. Axis of symmetry would be x equals 1. So I just come to my graph and I plot the vertex. It's right here at 1, 3. I can make that a little larger, 1, 3. And remember, the axis of symmetry would be the line going straight down right here. So I plotted the vertex. I have the axis of symmetry. It's at x equals 1. And I may want to tell the person I understand the vertex is 1, 3. So if you have Desmos, that's a very easy question. All right. Now, finally, solve each of the following by factoring. Yes, technically you could type them into Desmos and get the answers. This is something that I'm going to actually show you how to factor because it's better to factor. They don't always ask you for the solutions. They might ask you just for factored form. So you do need to know how to factor for the district assessment. All right, first thing I look at this, 3 and 49. Well, actually, I could just look at 3 and 14. 3 and 14 have nothing in common besides 1. So I go ahead and I make my factor x. And I am going to put negative 49 up there and 14 down here. Now I have a little calculator right here in front of me. Oh, that's easy. Well, I thought it was easy. It's negative 49. Oh, oops. The 3 right there makes it a little bit different. I have to take 3 times negative 49. 3 times negative 49. That's negative 147. And then I'm going to go play with 147. I just really don't know 147 very well. So let's go see. I know it's not divisible by 2. 49. Does 49 work? 49 plus 3 is 52. 49 minus 3 is 46. I want 14. That's not going to work. 147 divided by 4. Nope. 147 divided by 5 only goes in the anything with 5 and 0. So not 5. 6. 7. 7. 21 minus 7 is 14. That's what I want. So I am going to make this 21. And I'm going to make that minus 7. That is what I said, right? Yeah. Now, I could put x plus 21, x minus 7. The difference being, whatever this is, I now need to divide that by here. This is called slide and divide. 21 over 7 reduces to, I'm sorry, I just said the answer. 21 divided by 3 is 7. Seven over 3 does not reduce. So remember, you take this 3 and you slide it to the front. And you get 3x minus 7. Now, all of this equals 0 we're trying to solve. So when I solve x plus 7, what number plus 7 is 0? That's easy. That's x equals negative 7. But when I solve 3x minus 7 equals 0, not as easy, but it's still not hard. You add 7 to both sides. So then I get 3x equals 7. I divide by 3, and I get 7/3. So here I got also, for this part, 7/3. Now, if they said to factor it and that's all, you would type in x plus 7, 3x minus 7. If they ask you to solve, here you go. You could also use Desmos to get the solution. They would be the x-intercepts. Number 12. Oh, those are so easy. So this is 1. Those are so easy. Because you just put the 18 on top, the negative 9 on bottom, small numbers, multiply to 18, add to negative 9. Let's see, 2 times 9 is 18. That's not going to work. 3 times 6 is 18. But we want negative 9, so that'd be negative 3, negative 6. Negative 3 times negative 6 is plus 18. Negative 3 plus negative 6 is negative 9. So I get x minus 3 and x minus 6. What are the solutions? What are the x-intercepts? It'd be x equals 3 or x equals 6. So that means if I were to type this into Desmos, the x-intercepts are 3 and 6. All right, right here. Remember, if there's a negative, you need to factor it out first. That changes all the signs. That changes that to a positive x squared. That changes that to a plus x. Changes that to a negative 12. It negates everything. Now, I could put the negative 12 on top, the 1 on bottom. Where'd I get the 1? The 1 is from the 1x. So what multiplies to negative 12 but adds to 1? That would be 4, negative 3. So then the solutions would be negative 4 plus 3, but we'll get there. So then that factors into x plus 4, x minus 3. If they ask for the factored form, you're done. But the solutions to solve it would be x equals negative 4 and x equals 3, okay? Not too bad. Oh, and I forgot my negative out here from that negative. It doesn't change the solutions, but it does flip it over. We do need to preserve that negative. All right, this problem. All right. I look at my 4 and my 6, and you always look for a GCF first. The GCF of 4 and 6 would be 2. Now the GCF for x squared and x would just be 1x. Now what's left over? 4x squared divided by 2x is just 2x. Why am I writing so big? I don't know. 6x divided by 2x is 3. Now, what numbers make this 0? Anytime you have x by itself, you get x equals 0. That's one solution. Now, 2x plus 3, that might take some extra work. 2x plus 3 equals 0. You subtract 3 from both sides. You get 2x equals -3. You divide by 2, and you get -3/2. So my other solution would be x equals, might as well just keep writing this large, right? -3/2. Okay. That means it crosses the x-axis at -1.5. Okay, I am down to just a few minutes. I have 2 problems. We're doing great on time. This is called difference of 2 squares. Notice this variable is an n. Remember difference of 2 squares. You think of this in terms of squares. So 4n squared, that would be 2n times 2n. And for 49, that'd be 7 and 7. Oh, I failed to mention you should always look for a GCF. This doesn't have a variable. And then 4 and 49 have nothing in common besides 1. But your final problem, for your factored form, you do 2n plus 7, and then 2n minus 7. You take both of these together, put plus and minus. That gets rid of the middle term. Now we're trying to find the solutions. So I set them both equal to 0. If I set 2n plus 7 equals 0, I subtract 7 from both sides, and I get 2n equals -7. Divide by 2, and I get -7/2. So for this one, I get n equals -7/2, or -3.5. Now the other one is going to be very similar. You're going to add 7 and then divide by 2, so it's going to be +7/2. Okay, so there's my solutions. It's factored and I solved. All right, let's try the same thing. I see 2 terms. I start thinking difference of 2 squares, and then I think, uh-oh, 2 is not a perfect square. 2 is a rectangle, 2 times 1. So I cannot do this method on here. 18 is not a perfect square, because that'd be 2 times 9 or 3 times 6. There's no way to break that up without using square roots. And then I notice that there's a GCF, and I should take it out. So the GCF of 2 and 18 is 2. So if I divide both of those by 2, I get x squared minus 9. Now, there we go. X squared is a square. It's a perfect square. And 9 is a perfect square. X squared is just x times x. 9 is 3 times 3. So putting all that together, I'd get the 2 on the outside, x plus 3, x minus 3 equals 0. 2 doesn't change the solution, it just makes it skinnier. For x plus 3, it'd be x equals -3. For x minus 3, it'd be x equals 3. Those are my 2 solutions. All right, guys, I hope you take the time to review this, look it over. I know I went through this pretty fast. If you understand everything on this review, The test should be super easy. I do this to help you. I hope you did the review. I'll tell you what, if you send me a message in Canvas stating that you watched this video, then I will add some extra points into an assignment for your practice somewhere. Okay, so I'm just kind of curious, who actually watches these? Anybody? Just me? I spend a lot of time on these. I hope people watch these, but yeah, go ahead and actually I'll do better than that, and don't tell anyone. I'll add 5% to your test score. 5% if you email me and show me, or just tell me that, hey, I watched your review to the end. I will add 5% to your test score. All right, other than that, have a good day. Hope you made it this far in the video. Bye-bye.